everyone, welcome to Testronix Instruments. Have you ever wondered how a very small component can be inspected so clearly on a big screen? In many manufacturing parts, the important details are not always visible to the naked eye. A small hole, a tiny radius, a thread, pitch, a serrated edge, or a profile cut may look normal from outside, but it may still be dimensionally incorrect. This is where the digital profile projector plays an important role. It uses light, optics, magnification, screen projection, and digital measurements to convert a small sample profile into a large, clear, and measurable image. In this video, we will understand the complete working principle of a digital profile projector in a simple and practical way. The basic working principle of a digital profile projector is optical projection. The concept is simple. When light falls on a sample, the sample blocks part of the light and creates a shadow of profile. This profile is then passed through an optical lens system, magnified and projected on a large screen. So, the complete working path is light source, sample, lens magnification, projection screen, and digital measurements. The projected image helps the operator clearly see the profile of the sample. Then, using the XY measuring stage and digital readout, the actual dimensions are measured. This means the machine does two important things. First, it makes the profile visible by magnification. Second, it helps measure the actual dimension through digital movement. The first important part of the digital profile projector is the light source. The light source provides controlled illumination required to create the sample profile. Without proper light, the sample edge will not appear clearly on the screen. When the machine is switched on, the light passes through the stage area where the sample is placed. Depending on the type of sample and inspection requirement, the light helps create a clear outline or shadow of the sample. The quality of illumination is very important. If the light is weak, uneven, or not properly focused, the profile may appear unclear or blurred. And if the profile is not clear, the measurements may not be accurate. That is why proper illumination is the first step in accurate profile projection. After the light source, the next important step is the sample placement. The sample is placed on the glass stage of the machine. The stage must be clean and sample should be placed properly without tilting or unwanted movement. When light passes through or around the sample blocks the light and creates a shadow or profile. This profile represents the actual shape of the sample. For example, if we place a circular component, the projected profile will show the outer diameter and inner hole clearly. If we place a serrated sample, the projected image will show the depth, valleys, pitch, and edge shape. If we place a threaded component, the thread profile can be observed on the screen. That is why correct sample placement is very important. If the sample is not placed flat or if it's tilted, the projected profile may not represent the actual dimensions correctly. The third important part of the working principle is lens magnification. The profile created by the sample is passed through an optical lens system. The lens magnifies the profile and projects it onto the circular screen. This magnification is what makes the digital profile projector so useful. A small hole, a tiny radius, a small pitch, or a fine edge. Defects may not be visible clearly by eye, but once it is magnified on the screen, the operator can observe the profile much more clearly. This helps in checking whether the sample profile is correct or not. The lens does not change the actual size of the component. It only enlarges the visual image for easy inspection. The actual measurement is still taken from the precision movement of the XY stage and the digital readout. This is an important point to understand. The screen shows the enlarged profile, but the DRO gives the actual measured value. The magnified profile is displayed on the projection screen. The screen allows the operator to clearly observe the enlarged sample image. On the screen, we can see the edges, curves, holes, serration, thread, slots, and other profile details. The screen also has a reference line or cross line. These cross lines are used for alignment during measurements. For example, to measure width, the operator aligns one edge of the sample profile with the vertical cross line. Then the digital reading is set to 0. After that, the XY stage is moved until the second edge aligns with the same cross line. The reading displayed on the DRO gives the actual width. So the screen is not only for viewing, it is also used as a reference for alignment. A sharp and focused image on the screen is very important. If the image is blurred, the edge positions become doubtful. This can create operator error during alignment. That is why focusing the profile properly is one of the most important steps before starting any measurement. Before taking any reading, the operator must adjust the focus. Focus adjustment makes the sample edge sharp and clear on the screen. A sharp edge helps the operator align the profile accurately with the cross line. If the image is out of focus, the edge may appear thick, unclear, or shadowed. In that condition, the operator may not know the exact point where the edge starts or ends. This can directly affect the measurement results. For accurate measurement, always remember this sequence. Place the sample, switch on the lights, adjust the focus, align the edges, zero the reading, move the stage, and then take the measurement. A clear profile gives better measurement confidence. Now let us understand the XY measuring stage. The sample is placed on the stage. This stage can move in two directions, X direction and Y direction. The X direction is normally used for the horizontal movement and Y direction is used for the vertical movement. The operator moves the stage using hand wheels. As the stage moves, the sample also moves and the projected profile shifts on the screen. This movement is very precise. The machine tracks how much stage has moved and that movement is shown on the digital readout. So, when we measure a sample, we are not measuring directly from the screen size. We are measuring how much the precision stage moved from one reference point to another. This is the foundation of accurate dimensional measurement in a digital profile projector. The DRO or digital readout is the display system that shows the actual measurement value. When the operator moves the XY stage, the DRO displays the movement in digital form. It may show values for x-axis, y-axis, and other related measurement functions depending on the machine configuration. The operator can also set 0 at the starting reference point. For example, if we want to measure the diameter of a round component, we first align one edge of the circle with the cross line. Then we set the reading to 0. After that, we move the stage until the opposite edge aligns with the same cross line. The value shown on the DRO is the actual diameter. Similarly, for hole diameter, we align one inner edge, zero the reading, move the opposite inner edge and read the value. So the DRO makes the measurement clear, digital and easy to record. Now let us just connect all the steps together. First, the operator places the sample on the glass stage. Second, the light source creates the sample profile. Third, the lens system magnifies the profile. Fourth, the enlarged image appears on the projection screen. Fifth, the operator adjusts the focus to make the edge clear. Sixth, the operator aligns the sample edge with the screen cross line. Seventh, the DRO is set to 0. 8. The operator moves the XY stage until the next edge of feature aligns with the reference line. Finally, the digital readout shows the actual measured value. This is the complete working principle of the digital profile projector. The machine combines optical visibility with digital measurements. This is why it is useful for checking small and complex components. The working principle of the digital profile projector is very useful because it makes hidden dimensional error visible. A component may look acceptable by eye, but after magnification, small errors become clear. An oversized hole, incorrect pitch, wrong angle, poor edge cutting, or irregular profile can be detected before the part goes into assembly or final dispatch. This helps manufacturer reduce rejection, improve quality control, and maintain tolerance and avoid customer complaints. In short, this machine gives the quality team a clear visual understanding of the component profile along with the digital measurement system. To get accurate results, the operator must avoid some common mistakes. The first mistake is poor focus. If the profile is not sharp, the edge cannot be aligned correctly. The second mistake is tilted sample placement. If the sample is not properly placed, the projected dimensions may be incorrect. Third mistake is wrong zero setting. If 0 is not set at the correct reference point, the final reading will be wrong. The fourth mistake is fast movement of the stage. The hand wheel should be moved smoothly for accurate alignment. The fifth mistake is dirty glass or sample surface. Dust, oil, or particles can affect the clarity of the projected profile. So, accurate measurements depend not only on the machine but also on proper operating method. A digital profile projector does not simply show a bigger image, it reveals the real geometry of the component. It uses light to create the profile, optics to magnify the detail, and digital measurements to confirm the dimensions. Because in precision quality control, every edge, every hole, every pitch, and every angle matters. When small details decide big quality, the digital profile projector brings them into clear focus. For more such videos, you can visit to the website www.testronicinstruments.com today. Thank you for watching and stay connected.